If you try to open a high voltage line directly, the current will arc across the gap. This electric arc can reach 9,000 degrees Celsius, hot enough to melt the switch. To solve this, a special device is used, the SF6 circuit breaker, or SF6 gas. It's much denser than air, so a tinfoil boat can easily float on it. When poured, it acts like an invisible liquid that can even extinguish flames. Crucially, it has a strong ability to absorb free electrons, making it an excellent electrical insulator. Inside the breaker is a fixed copper rod and a movable hollow copper tube. The bottom of the tube is attached to a piston inside a cylinder filled with SF6 gas. A mechanical system of springs and gears controls the up and down motion of the tube. When the contacts are connected, the circuit is complete and a powerful spring is held in a compressed state. When sensors detect a current fault, they send a trip signal to a relay. The relay's plunger hits a latch, releasing the spring's stored energy, which forcefully pulls down a connecting rod. This turns a drive shaft, which simultaneously pulls down the copper tubes in all three phases. As the copper contacts separate, an intense electric arc forms between them. Simultaneously, the moving tube compresses the piston, blasting a high-pressure jet of SF6 gas that completely extinguishes the arc. The circuit is now safely open. For added insurance, a manual disconnect switch is also opened. This entire process happens in just a few milliseconds. This is important because many faults, like those from lightning or birds, are only temporary. To avoid a permanent outage, the breaker automatically attempts to reclose. A second spring and relay are used for this. This relay releases the red spring, which rotates the gears in the opposite direction, pushing the tube back up to close the circuit and resetting the green spring. If the fault is still present, the breaker trips again and stays open, waiting for maintenance. That is how a high-voltage circuit breaker works.